You know when you look at a mountain range or just a huge, sprawling landscape, and you wonder, how did all this get here? We see these massive, permanent-looking things, but what if I told you their real story is hidden in plain sight?
Yeah, we see the world on this huge epic scale, right? Towering cliffs, giant rock formations, they just feel like they've been here forever, carved out by wind, water, and just immense, impersonal forces.
But what if we zoom in? I mean way in, down to a level you can't even see, because it's here, in this invisible world, that we find the planet's real architects.
And that brings us to the big question for this whole explainer. What if the largest, most solid features of our world, the mountains, the soil, maybe even the air we're breathing, were actually constructed by the tiniest forms of life?
So, here's our game plan. We're going to meet these invisible architects, see how they became builders of rock and mountains, then how they engineered living land. After that, we'll look at how we're starting to harness this microbial workforce, and finally, what our future with these builders might look like.
All right, so let's get into it. Let's meet this unseen workforce. I want you to think about microbes a little differently. Not just as tiny things living on Earth, but as a literal planet-wide construction crew. And they've been on the clock for, billions of years.
And believe it or not, this isn't some brand new, crazy idea. This quote from 2008 really nails it. Minerals at the Earth's surface have begun to co-evolve with microbial life. Basically, the moment life showed up, it started messing with the rocks. They've been in this dance together from the very beginning.
Okay, so let's start with their biggest, most ambitious projects. We're talking rock and mountains. This is where microbes really leveled up, going from just, being alive, to becoming the planet's first master masons.
The secret sauce here has a fancy name, biomineralization. It sounds complicated, I know, but the idea is actually super simple. It's just life making minerals. That's it. Microbes are basically taking their biological leftovers and turning them into solid rock.
And this is where the scale of their work just gets mind-blowing. Okay, so picture this. About 2.5 billion years ago, you've got these ancient cyanobacteria just pumping out oxygen like crazy. When they died, their bodies, which were full of carbon, got buried in the sediment. This created these really slick, slippery layers deep in the earth that, get this, acted like grease for the tectonic plates. It literally lubricated them, making it way easier for them to crash into each other and shove upwards, kicking off this huge global mountain building party. I mean, think about that for a second. The Himalayas, the Alps, their existence was basically kickstarted by tiny little organisms in an ocean billions of years ago. Yeah, bacteria helped build mountains. It's wild.
And what's so cool is how much control these little guys have. It's not just random. Look at this. Researchers found that this one bacterium can create completely different crystal shapes just by changing the blueprint. If it uses its own body as a template, bam, you get these perfect hexagonal prisms. But if it uses the gunk it secretes around itself, you get these awesome little donut-shaped crystals. That's not an accident. That's precision engineering on a microscopic scale.
All right, so they built the foundations, the rocks. But it doesn't stop there. Let's move from that ancient rocky past to the living, breathing land that we all depend on. Because it turns out these microbes aren't just masons. They're also incredible weavers.
So, say hello to this little guy. This is a type of cyanobacteria, and these tiny little threads are basically master terraformers. In some of the harshest deserts on Earth, places where nothing else can survive, these are the pioneers. They're the ones who show up first and start the incredibly long, slow job of turning dead sand into living soil.
So what's their secret? How do they pull this off? Well, it's all about this stuff they ooze out called extracellular polymeric substances, or just EPS for short. The best way to think of it is like a biological superglue. It's sticky, it grabs onto sand grains, binds them all together, and creates this stable structure that can hold onto water and nutrients. That glue, that's the literal foundation of soil. It's what gets the whole ecosystem started.
And the results are just wow. Take a look at this. This is from an experiment where scientists basically just added these cyanobacteria to plain old desert sand. In only 5 years, look at the compressive strength. It went from nothing, it's sand, it just falls apart, to over 100. It became stable. And total nitrogen, which is like superfood for plants, is shot up by more than 20 times. This isn't a small change. This is turning one thing into something completely different.
So when you see that kind of power, you can't help but ask the next big question, right? If microbes can do all this on their own, what could happen if we actually started working with them? And that question is taking us into this amazing cutting-edge field, bioconstruction.
I mean, seriously, what if our buildings could heal themselves? Like you get a crack in a wall and it just fixes itself. It sounds like something straight out of a sci-fi movie, but it's not. By putting microbes directly into building materials, scientists are actually making this happen.
And the way it works is just so elegant and simple. You mix these dormant bacterial spores right into the concrete when you're making it. They just hang out, asleep. Then a crack forms, water gets in, and that water is like an alarm clock. It wakes the bacteria up. They start eating some food that was packed in there with them, and their waste product is, you guessed it, calcium carbonate, limestone. They literally poop out the exact material needed to fill the crack and heal the concrete from the inside out. It's brilliant.
And it's not a one-size-fits-all solution either. Think of it like a menu. Scientists are trying out all sorts of different recipes. Some use bacteria that thrive on urea, others use ones that munch on calcium salts. They're even looking at using super tough fungi that can handle the crazy harsh environment inside concrete. It's a whole field of exploration.
All of this is really opening a wild new chapter in how we think about the microbial world. We're shifting from just being amazed by these tiny builders to actually teaming up with them, you know? A real partnership.
Of course, a partnership like this has to have some ground rules. It's not the Wild West. You can't just go cook up some engineered microbes and dump them outside. In the US, for instance, you've got agencies like the USDA that keep a really close eye on this stuff. Their main job is to make sure we don't accidentally cause some huge problem for plants or farming. You need permits, you need oversight, you've got to be careful and smart about it.
So here we are, back where we started, but hopefully with a totally new way of seeing things. The world we're standing on wasn't just settled by microbes, it was built by them. The mountains, the soil under your feet, and maybe someday even the buildings we live in. It really just leaves us with one massive question. Now that we know, what are we going to build together next?